Hi guys, hope you're well guys. MIP 1502 student, this video is for you. Even if you're not doing MIP student, even if you're not doing MIP, or even if you're not a student who's doing MIP, this video is for you. As we all know, there's always a room for learning. If you're new to this video, if you're new to this channel, kindly subscribe. You only subscribe once. Thank you for those who have subscribed, and for those who keep watching the videos. We really appreciate you guys. So let's start with linear pattern. So when we talk about a linear pattern, we are talking about a pattern that has a common difference, that is a common difference. That's the pattern that we are talking about. Okay, it has a difference, or what we call a constant difference. A constant difference. So let's consider that we are having 3, 5, 7, right? Maybe 9. Okay. So we need to find the other consecutive terms. So guys, first thing first, we will say term 2 to get the constant difference. It's D, which is term 2, which is term minus term 1, which is equals to term 3 minus term 2. So meaning that this will be term 1, and this will be term 2, and this will be term 3, right? So what we are going to do, we are going to say we're having 3, 5, 7, as well as 9. So this is what we are going to do, guys. We are going to say 5 minus 3, it's going to be 2. 7 minus 5, it's going to be 2. 9 minus 7, it's going to be 2. So you can see this is a constant. There's a constant or a common difference in this, because when you subtract 5 minus 3, we get 2. So 7 minus 5, that's 2. Then 9 minus 2, that's 2. So to get the other consecutive term, this is what we are going to do. 3 plus 2, that's 5. 5 plus 2, that's 7. 7 plus 2, that's 9. So remember, the other consecutive term that will follow here is also 2. 9 plus 2, remember that's 10, 11. So that's 11. So in other words, here we are going to have term 4 as 11. Right. Hope you saw, guys. So the other term that follows T4 or term 5, also we are going to have the constant difference of 2. So remember that we're having 11 now. So it's going to be 11 plus 2. What is that? 12, 13. So we are having 13 as our fifth term, right? We're having 13 as our fifth term. So this is how a linear pattern works, right? So another thing, they will ask you about an algebraic rule in terms of the linear pattern. They will ask you an algebraic rule, or an end term, or they could say, or a general term. So let's work out this. Let this difference, we're going to say D, and this is our first term. T1 is our first term. So for you to get the general rule, we use this formula. Tn is equals to A plus N minus 1 D. So this is the formula that you're going to use to get a general term. So first thing, collect the data. What is your first term, which is A? Your first term is 3, term 1. Then what is your difference? Your difference is 2. So you ask yourself, what is N, guys? N represents position of the term. In this case, it's a position of a term. It represents the position of a term. So all right, so what are we looking for? We're looking for the general term. Actually, we're looking for what is Tn is equals to this. Let's put A. What is A? A is 3 plus N minus 1. Then the difference is what? It's 2. Right? You can see how I substituted my values, because A is given as 3, then difference is given as 2, and hence we have N minus 1 as shown here in the formula. So after that, you work out your bracket. So it's going to be 3. We'll start with the brackets first, using BODMAS. 2 times N that's going to be 2n. 2 times negative 1, that's going to be negative 2. Remember that this 2 multiplies everything that is inside the bracket. So from here, we are going to collect the like terms. 3 minus 2, that is going to be 1. So we are having our general term or our algebraic rule as Tn is equals to 2n plus 1. So you can check by substituting here at the position. Let's say we put position 1 to see what are we going to get. What are we going to get there? So let's say 2 times 1. 2 times 1 is going to be 2 plus 1 is going to be 3. Then let's put 2, position 2. 2 times 2, that's going to be 4, plus 1, that's going to be 5. Njalo njalo. That's how it should go, right? That's how it should go. Right. Another formula that you could use, or another alternative that you could use, it's let's say, guys, we're having 3, 5, 7, 9, 11. Okay, so remember that the difference is 2 here, the difference is 2, the difference is 2. So let this difference be b, and let the first term be b plus c. So let's work it out. So when you are using this method, you are following a linear equation standard formula which says Tn is equals to Bn plus C, right? So let's work it out. Our difference, which is B, is equals to 2. Then we're looking for the first term there, it's B plus C. What is first term? First term, it's 3. You will put 3 here. So where there is B, you're going to put 2. So it's going to be 2 plus C, which is equals to 3. So C will be 3 minus 2. So what is C 3 minus 2? That's going to be 1. So you can see we already have C as 1. We already have B as 2. So what we can do is to substitute here. So we're going to, where there is B, place what? Place 2. So it's going to be 2n. Where there is C, you place 1. So it's going to be Tn is equals to 2n plus 1. That's how it should be. So I hope, guys, you have learned something from this pattern, which is a linear pattern. Remember, we only know that it's a linear pattern, or we can just say an arithmetic. Sometimes it's called an arithmetic pattern or a linear pattern. How do we know that this pattern is a linear? First, check the difference. If the difference is the same, or it's constant, just know, or it's common, just know that it is a linear pattern or an arithmetic pattern. Hope you find this video useful. If you're new to this channel, what are you waiting for? Let's subscribe as we are growing as a community. And remember, we love you.